Okay, so we're going to go over max and minimums of quadratic functions. We're going to talk about the three different forms that we use to write a quadratic function. The very first one we have up there is called the standard form. Okay, so this is considered standard form. Okay, these are all forms. And we'll talk about how to go from one to the other just for helping sake. The second one, this is called vertex form, and they each have a reason for being called this, okay? And finally, the last one is called factored form. Now, all three of these can represent the exact same equation, exact same parabola when we graph it. The only difference is they just represent them in different ways. Now, standard form is set up this way so that you will see that the variable with the highest exponent is first, and the variable with the next highest exponent is second, and then the last one is the constant. They consider that standard form. It's the way you usually see a polynomial, or in this case, they call it a trinomial because there's three of them, three terms. Vertex form, the reason they call it vertex form is the h and the k, whatever their values are actually the vertex. They're telling us exactly where that vertex is. Okay, so if you recall, a parabola is like this, or it goes this way. Vertex is either the highest or lowest point, also known as the max or the min. This is the easiest form to find max or min in. Okay, because as soon as you have it, your h value, and I'll write this over here, the h value, and then the k value, I don't think I got that. There you go. And the k value actually represent your x and y. Okay, so what that means is, and it's technically negative h, is your k value or x value, and your k is your y value. So whatever those numbers are, and we'll take a special, let's say that k was 5, well that means your y value of a vertex would be 5, and if h was negative 2, well, we take the opposite of that. So the x value is positive 2. So your vertex would be at positive 2 and 5. So it's the easiest one to tell, especially when solving max and min. This is the exact point. That would be the coordinate of the vertex of it. Hence why they call it vertex form. And finally, factored form is the easiest way to find the x-intercepts. The r and the s tell you exactly where the x-intercepts are. So if you remember what we mean by x-intercepts, and we'll just draw a quick makeshift graph here. Let's say we had a parabola like this. Okay, the x-intercepts, we'll do that in blue, on the x-axis, exactly. And the s, let's say it's positive 5 in this one, and it was negative 7 in this one here, okay? What it'll be is they'll actually be reversed, okay? So because it's positive 5 here, when I write in here, it'll actually say x minus 5 in the bracket, okay? And in this one here, because it's negative 7, it'll say x plus 7, or something roughly around that. Those are the basic forms of it, okay? So that's the easiest way to find the x-intercepts, but not technically the vertex, and that's what max and min refers to, is a vertex. So the very first thing we want to actually be able to tell is if something has a max or min. Oh, I'll quickly go over how to go from one form to the other, and then we'll go to the easy part, which is the question. To go from standard to vertex, it's called completing the square. Complete the square. Okay? To go from standard to factored, we use something called factoring. Makes sense, right? And then for both of these, to go from vertex to factored, the fastest way would be a type of expansion. So we don't really talk about it. Usually the easiest way would be actually to backtrack, okay? And in order to go from vertex to standard or factored to standard, we expand and simplify, okay? We always do that, expand and simplify. So that's how we know to go from one to the other. These are the styles we use. But the most important thing is a max or min. How do I know if a parabola has a max or min? Well, it completely depends on the one variable that's the same through all of them, which is our a.
I understand that.
Okay? And if an a is positive, which way is it going to open?
Up.
Yep, simple as that. So as long as the a is positive in any of these, it opens upward. And if a is negative, it opens down. Simple as that. So here's the trick, though. If something, and we'll make another makeshift graph here just so we can talk about it. If something is opening downwards, does it have a max or does it have a minimum?
If it opens up, it's the minimum. If it opens down, it's the maximum.
Yes, okay? And the reason being for that, it seems counterintuitive. You think down would be a min, right? But the reason for that is because when we go down, it'll never stop. So there is no stopping point. But because it's facing down, the vertex is the highest point. Or in other words, it has a max. Remember we talked about domain and range? This is the highest it'll go. So this is the maximum value of this. Okay? And vice versa, when it's going upwards, this is the lowest point on the y-axis it'll go. So in other words, it's the most minimum value it could possibly reach. So that's how we know. So it's kind of counterintuitive. When it's facing downwards, we have a max. And when it's facing upwards, we have a minimum. Okay? So that'll actually help us with the first two questions. Let's try using that knowledge.